Mtazifunga kesho.
Yeah. Believe I'm live as well. Just go ahead and open.
Okay. Mtu ataweza kuedit afterwards.
Yeah, you can.
Cool. That would be better. Okay, let's go.
Yeah. A minute. Just need to confirm that everything is okay and then you're good to go. Yeah, I can see your stream as well. Yeah, you can go ahead and start by the way. Do the introduction and then I'll continue from there.
Why? Production, not that.
Hi guys. So today we were to go through. Actually, this is our first live stream, and we wanted to go over a few things that came across, especially when it comes to coding and coding challenges that we encounter. So this is going to be a series that we'll be going through. I and I'm joined as well with Mike. You can check his channel down on the description below. His channel is Mike Madhu KE. Just make sure you go and subscribe to him. So the main challenge was that I was trying to do some general mathematics. Actually, I had an app that I was working on, and it involved doing calculation for the amount. It was like it was managing currency. I don't know how best to explain that, but it was more of a financial application. So the challenge was that when I was doing the calculations, the math wasn't adding up, if that makes any sense. In terms of this, if I did the same math using a calculator, the output was always different. I'll show you an example right now. And for example, in JavaScript, if I do this 0.2 as such, the output will be something like that. But just for the demo, I created just a playground for us to test. And then save that. As you can see down here, it's always
Sorry, James, I can't see your screen.
I believe you're sharing the wrong screen based on what I'm saying. Double tap my stream. Can you see it? The other one, not that one.
Which one? This one?
Oh, sorry.
This one is me.
You should see it now. Check. What stream? The other one.
And just a second. Yeah, there we go.
Yeah. So, as you can see on my screen, if you try to add a 0.1 plus a 0.2, you'll always get this weird number.
That's weird.
And then at first, actually, I thought that this was a JavaScript problem. Actually, for real, I was living okay knowing that this one is just a JavaScript problem because I always assumed at the back of my head, since most of the things that we do in terms of doing calculations or analysis, we always use Python or maybe let's say R. There are calculations in maths that will always be accurate. And then I just sat down and thought, maybe, what is the harm in actually to check what's the same output on on those different languages? And which I went ahead and I did try that. For example, if I do the same on Python, uh, select the same, I still get the same output. Now that got me even more curious. So I didn't stop there, actually. I decided to even try one more language just to confirm. So this one was using Dart. I'll still run the same code. That will be 0.1 plus 0.2. Uh, Still, there are chances that I'll still get the same output. So, what do you
Yeah.
think could be the problem?
Mm.
Maybe
Um,
Meiko, you can go ahead and take us through what you think, or is it something that has always been there? I don't know. I am yet to find out because now I was more curious on why is this happening.
yeah, first of all, I'm usually a fan of low-level languages, so my first thought will be, this sounds like a high-level language problem. So maybe I can try on let's say C++, the low level. Just going to create a small solution here.
Mm-hmm.
Um, Create a new project. Just going to create a test solution and then see what it is because that's very weird.
I know.
I how and it's across all languages. Maybe it's in all. I don't know.
Maybe you don't know. It's to say because I thought because of how simple it is, at least I should be getting since example a calculator is made by a programming language, so such things should not actually be happening. If that makes any sense.
Yeah, and that could be very yeah, it could be very dangerous even.
Yeah, I know.
Because if you're making a real world application expecting it
I think I lost you.
to be accurate, then if that is happening, that'll be very
Yeah,
terrible.
yeah, but actually, just imagine if you're doing, let's say, a banking system, and then you're just trying to do the basic like maths for each time they top up the account balance,
Point one plus.
or they do a withdrawal. You'll either be stealing from the client, or the client will be stealing from you, if that makes any sense. So it will be ironical in
Yeah,
some kind
true.
of way.
Huh, okay.
Hmm.
Yeah, yeah, very, very true. And you could maybe you can even get jailed for changing
Yeah, I know.
figures. Well, it's not really the thing that's happening. Oh,
Yeah.
look, okay. The result I'm getting here is 0. Um, However, let me just check with the debugger
Mm-hmm.
because I know sometimes C++ truncates when you're printing out.
Mm-hmm.
So let me just do it with variables. So I'll just declare a float. Let's say A, float B, and then I just assign it to another float C. Let me call it A plus B or something like that. And then, oh, there's an error here. And then I'll just put a breakpoint and then look at it from the debugger so that I can look at the memory.
Yeah. Okay.
Oh, look at that. You can
Yeah.
see 0.1 has a funny figure, 0.2 as well. Let me just move this second section. Oh, look at that. When you're adding them,
Yeah. I know it's weird.
look at this. What is this?
That's really like that's very
Okay.
weird. 100%. Like, I am. So does that mean that at the point where you're running, somehow at the end of it, it's getting truncated? The rest of the numbers at the end.
I don't think so. I mean, for this one, it's just because I'm printing. When it's printing, it will truncate, but it's not that the actual value has been truncated. So whatever is stored in memory is the actual value.
Okay.
Whatever we're seeing when it's printing here,
Mm-hmm.
let me just go to this. This output is not what is actually stored in memory
Okay.
because, of course, we have seen those extra digits.
Yeah. Yeah.
So this is just what you're seeing, but it's not what is actually in memory. So I'm curious. Let me just try to see online.
Mm-hmm.
Um, First of all, how do computers convert data into binary? Um, okay. Of course, we know. I don't know if you remember from school, converting. I remember us doing conversion for integers, which
Yeah.
was very straightforward, but I don't remember for floating point numbers.
Okay.
So I remember for here we go, floating point numbers.
Mm-hmm.
I don't know if you remember for integers.
Yeah, I do. I do. I do. But just for the sake of whoever is watching, you can just try and explain it out.
Yeah. So let me just open Notepad here. I hope it will make sense. So if, for example, you're trying to check the binary digit of 4,
Mm-hmm.
so every time we'll just divide it by 2 here,
Mm-hmm.
then he'll get 0, and the remainder will be
Okay.
0. I mean, sorry. It will go twice.
Mm-hmm.
Remainder will be 0.
Yeah.
My bad.
Yeah.
Here, 2 divided by 2, we
Mm-hmm.
get 1, remainder of 0.
Mm-hmm.
Then we take 1, divide by 2, we
Get
get 0,
0.
remainder of 1.
Yeah.
And then our binary value will be which is going up. So 100
Mm-hmm.
base 2.
Mm-hmm.
So now this will be our binary number. This